Hello, my dear students. Let us discuss about the consistency of precipitation data by double mass analysis. Double mass analysis is a commonly used data analysis approach for investigating the behavior of records made of hydrological or meteorological data at a number of locations. It is used to determine whether there is a need for corrections to the data to account for changes in data collection procedures or other conditions. Such changes may result from a variety of things, including changes in instrumentation, changes in observation procedures, or changes in gauge location or surrounding conditions. Double mass analysis used for checking consistency of a hydrological or meteorological record and is considered to be an essential tool before taking it for the analysis purpose. Actually, this is a mass. This is a graph of showing the double mass curve analysis, accumulated annual values at 10 stations. This is in x-axis. Y-axis is accumulated annual values at station X. Okay. Then you have to draw the slope. From this slope, you will get some values. Based on that, you can find the results. Here, the double mass curve is obtained by plotting x-axis, that is average accumulated precipitation of nearby station, and y-axis is accumulated precipitation of the station under consideration. So what you have to do, arrange the data, resend to past, then determine the cumulative rainfall of the subjective station and of the nearby stations. Then draw the double mass curve. Part of the curve which lies in straight line requires no correction. All data lying after the deviation point from the straight line requires correction. To determine correction factor, calculate the slope of the curve before and after the point of deviation. So this is the formula to find that correction factor. After that, to determine the correction factor, calculate the slope of the curve before and after the point of deviation. Finally, you have to find what is the corrected value, that is given by PA is equal to SA divided by S naught into P naught, where PA is adjusted precipitation, PO or P naught is observed precipitation, SA slope prior to the break in the curve, and S naught or SO slope after the break in the curve. Actually, overall what you can say that it is a technique used for checking the consistency of a record. The trend in the rainfall records at a station may slightly change after some years. Mainly because due to the change in the environment of a station, or tampering of the instrument, or shift in the observation practices. The change due to meteorological factors will equally affect all the stations in the test and thus will not cause a lack of consistency created by the external effects. So usually it is a graph I have shown already. It is a double mass curve is a graph plotted between the accumulated annual rainfall at a given station X, that is a test station, versus accumulated annual values of the average of the group of the base station for various consecutive time periods. Here you can see this. A break in the slope of the resulting plot indicates the change in the precipitation regime of station X. Okay, so here the precipitation values at the station X beyond the period of break are corrected by the following relationship that I have told already, that is this. Okay, here I've told what is that corrected precipitation at that station X, and adjusted precipitation, and other one is observed precipitation or recorded precipitation. Okay, let us see one example. This is the annual rainfall at station X and the average of annual rainfalls at 10 surrounds base station in centimeter are given below for a period of 16 years starting from 1970. Check whether the data at station X is consistent, in which year a changing regime is needed. Compute the adjusted annual rainfalls at X for the affected period. So here this is given here. This is the given problem. I have told you have to write from the recent to the past. So here it starts from the year 70, and this is the rainfall, and this is 10 station average. Okay, next is it starts from 70 and 85. So first we have to write the recent one, that is 1985. So that's why it is written here 1985, 1984, 83, 82, 81 till 70, and respective rainfalls are noted down. That is what 69, 55, 62 that. Okay, here then 10 station average that is also given, that is okay, that is given. Next you have to find the cumulative rainfall. How you can find the cumulative rainfall? 69. Next is 69 plus 55, 124. Then 124 plus 62, 186. 186 plus 67, 253. 253 plus 87, 340. 340 plus 70, 410. 410 plus 65, 475. Like that you have to find the cumulative rainfall at X. Okay, then average of annual 10 base station, that is given, that is here 77, 62, 67, that 77, 62, 67. Well, here also you have to find the cumulative rainfall of the base station. The first one is 77. Next is 77 plus 62, 139. 139 plus 67, 206. 206 plus 68, 274. 274 plus 86, 360. Like that you have to add, and you will get the final cumulative rainfall. Okay, so this is the first step. So first you have to list out the data of annual rainfall and cumulative rainfall. Okay, then average annual for the 10 base station and cumulative station. After that you have to draw the curve like this. This is for accumulated annual values in 10 stations and accumulated annual station annuals at station X. Okay, then what you have to do here, the data are plotted. The data are plotted as shown in the figure. From the figure we can observe that graph is not having uniform slope. You can see here it is not uniform slope. See till here it is like this till B. Okay, straight line. After that it deviates. That is you can clearly observe. So there is break at point B. Hence record at X is not consistent. So there is a break here. So the consistency is record is not consistent. Thus change in the regime is indicated in 1978 corresponding to point B. So you can see here at this point there is a change, that is year 78. Okay, so this point is for 78. So there is a change, so that you have to note down. Thus change in the regime is indicated 1975 corresponding to point B. Now you have to calculate the slope, that is A divided by B. A is this one, this here, find the slope of this, and this find the slope for this. This is before the changes, and this is after the changes. Okay, so A divided by B, A you will get 27.5 and B you will get 39. So you will get A divided by B is equal to 0.7051. Once hence the data beyond point B are to be corrected in the ratio of A divided by B, means this. So after this point, 1978, the data has to be corrected. So adjusted cumulative in 1970. So for all this data from 1970 to 78, we have to correct the value by using this formula. That is what I have given. Same thing, A divided by B, instead of that I have given here this formula, SA divided by S naught into P naught. Same thing, in different textbooks they use the different notations. So in this book it is given Px into A divided by B. Okay, so that is 0.7051. Okay, now what we have to do, this is the already given here for 1970, 95. Can see here for 1970 it is 95, 1971 75. So same thing you have to write here. First observed rainfall it is. It is observed rainfall. After that you have to correct this. That is adjusted rainfall. That is given by 0.7051 into Px. That means for 1970, 95 into 0.7051, that is 67. 75 into 0.7051, 53. Next 90 into 0.7051, 63. Like that for all the value till 78. 77 is the last value you have to calculate. Okay, this in this way you can find the consistency of the record. I mean, if there is any changes in the curve, you can make out using this analysis. I hope all of you understood. Thank you.